Hey, welcome back. So anytime we've got a shared electron pair, this is what we're going to call a covalent bond. And so co is letting us know there's two of them. Valent is telling us that it's actually the outer electron. So a covalent bond is a bond that is formed by sharing pairs of electrons. And those electrons now are between two nuclei, and so they're attracted to the nuclei of each atom, and so that makes it stable. Every time we do that, we get a covalent bond. Now, the atoms are generally going to want to have either two electrons around them on the outside, which we call the duet rule, and really hydrogen and helium are the only two that are going to do this. Almost always they're going to want 8 electrons on the outside, which is what we call the octet rule. Okay, and why is that? Well, I'm glad you asked. So the duet rule comes from the fact that the first shell of electrons can only hold 2, so that is 1s2, and then at that point they're full, so poor old helium and hydrogen can only have 2 electrons on the outside. But the octet rule really comes from the fact that the second and third period elements, well, they're going to want to have 2s2 and 2p6 on the outside, or 3s2 and 3p6 on the outside to fill up. And so you can see there that gives you a total of 8 electrons on the outside. So if we take an example of a molecule like water, let's say, so hydrogen's in group 1, oxygen is in group 6, so we put 6 valence electrons around, and hydrogen is in group 1, and as they come together and bond, then that electron by the hydrogen, right, is going to share with that electron by the oxygen, and the same thing on the other side. And so this is what the molecule looks like. Why is this so stable? Well, if we look around the hydrogen, we can see we've got 2 electrons. So it's got a full outer shell, right, 1s2. And if we look around the oxygen, we can see it's got 8 electrons around there. So that is satisfying the octet rule. We can see this has kind of got that 2s2, 2p6 full outer shell. And again, the hydrogen over there is exactly the mirror as the one on the left. Now, because it's kind of a pain to write all these dots in, we'll often instead write a line every time we've got a covalent bond. And so the other way to write this molecule would look something like this. So this line here is a single covalent bond, and so is this one here. And these pairs of electrons that aren't involved in bonding, these are what we call lone pairs or non-bonding pairs, so you can call them whatever you like, as long as you use one of those terms there. So non-bonding pairs, or NBP for short, I suppose, or lone pairs, LP for short. And so these are the bonds, so sometimes we call them BPs, and that stands for bonding pairs. So we said earlier that a bond is where you share a pair of electrons. Well, you can actually share 2 pairs of electrons, and so that would be 4 electrons total, and you can actually also share 3 pairs of electrons, and so that would be 6 electrons total, and you make what's called a double and a triple bond. So for instance, if we take our friend oxygen, we know oxygen is one of those diatomic elements. Oxygen is in group 6, so it actually has 6 electrons around it, and we know it's diatomic, so we're going to take not 1 but 2 oxygen atoms here together. And as we bring them together, we can see that the only way to make this stable is to get 8 electrons around the outside. And if you've only got 6, that means you need 2 more. So this one and this one is going to be shared over here and here. And likewise, this oxygen over here needs 2 more. So this one's going to be shared and this one's going to be shared. And that gives rise to the double bond. And so if we go ahead and we write, so those are the lone pairs. And there's the first shared pair and the second shared pair. And that is our Lewis structure for oxygen. And remember, we normally write a line for each shared pair of electrons, and so since there's 2 pairs being shared, we write a double bond right so. So this is what we call a double covalent bond. Sometimes we drop off the word covalent and we just call it a double bond for short. Other atoms that can form more than a double bond are things like nitrogen. Nitrogen can actually form a triple bond. Nitrogen actually has 5 valence electrons. We recognize it as one of those diatomic elements, those 7 diatomic elements from the intro to the course. And so we have 5 valence electrons around there, so we need 3 more. So these 3 electrons and these 3 electrons are all going to be shared between the 2 atoms, and that's going to form ourselves a triple bond. So we can write it like so. Or if you prefer, right, we can go ahead and we can say that's 1, that's 2, that's 3 shared pairs of electrons there. And that gives rise to our triple covalent bond, or just a triple bond for short. And why does this work? Well, if you look around each atom, you can see that there's 8 electrons, right? So that octet rule is being satisfied. So essentially that S2 and that 6p configuration is completely filling the outside of the molecule. and again over here, right? So you got 8 electrons over here, so it satisfies the octet rule. Now, this is kind of interesting actually, because if you look at these different situations, we've met single bonds, we've met double bonds, and we've met triple bonds. And it turns out a single bond is actually the weakest kind of bond, and a double bond is a little bit stronger, and a triple bond is even stronger still. So you can imagine each bond, right, it acts like glue, and the more glue you use, the stronger it is. So what we find is that in general, as we go from single to double to triple, the bond strength increases. And we also notice too that the bond length decreases. So the more tightly held together they are, the shorter the bonds are.